For my project, I analyzed the control system of the overhead bridge crane. A typical overhead bridge crane is controlled by a control pendant. This pendant hangs from the frame of the crane, and the crane operator controls the movements of the crane from the ground. The pendant is linked to the crane's motors and drives by a control cable. This cable runs on loops that hang from the bottom of the crane frame. These loops allow the operator to operate the crane from any position underneath it. To set this problem up, the loops are modeled as individual links, and the control pendant is modeled as a pendulum with the mass concentrated at one end. In this first example, the operator releases the control from a given position and watches the control move back to its home position. Another interesting scenario is when the operator pushes the control pendant away from the home position. The control pendant moves away and the loops slowly stretch out. Then the pendant slowly moves back to its home position. A final example is what happens when the operator tries to whip the pendant. This results in the pendant moving one way and the slider over the pendant moving the opposite way. The pendant tends to swing back and forth and not move very far along the crane frame. Eventually, the pendant will move back to its home position. Some ways to improve on this project are to improve the modeling of it, use more links, and try to get stiffness and damping values that match the material properties of the control cable. While the responses presented in this video do closely match what happens in real life, they could be better approximated by using more accurate parameters to set the problem up.